Take a look at this question. Now, again, this is sort of a combination between atomic structure and topic 12 and periodicity or trends in the periodic table. And the trend in the periodic table that we're looking at this time is the trend in atomic radius, which is effectively the size of the atom. And the key to this question here really is that atomic radius is dictated by the effective nuclear charge, or ZF. Now, some books don't refer to effective nuclear charge at all, but the general idea of effective nuclear charge is how effective the nucleus is at holding on to that outer shell electron, those valence electrons. The general trend in atomic radius is that atomic radius gets smaller as you go across the periodic table from left to right. So as you go across the periodic table from left to right, atomic radius will decrease. Atomic radius will decrease. And this is simply because of the fact that you're adding more and more protons into the nucleus. So you had this before in a previous question. So atomic number is increasing as you go across the periodic table, but the radius is decreasing. So you might start off with a radius like this for a sodium atom and end up with a radius like this for an argon atom. So as you go from left to right across the periodic table, the general trend in atomic radius is that it decreases because you get more positive protons into the nucleus, and so the nucleus's effective nuclear charge increases. Now, we've had this before as well. As you add a proton, you add an electron each time as well, but because those electrons are being added to the same energy level, they're the same distance from that nucleus, and so the nuclear charge is still as effective. So that's the general trend in atomic radius. Now in this question here, they want you to rank these four species, these four particles, and they're all ions, 2 cations, magnesium and aluminium, and 2 anions, sulfide and chloride. They want you to rank these 4 ions in order of decreasing size. So basically we need to start with the largest size and then go down to the smallest size. And as before with any questions where you're answering questions on periodic trends in atomic structure, it's usually a good starting point to write out any electron configurations that you can. So for that reason, I've included this little section of the periodic table to help us with that. So let's start off with the sulfide ion. Now, sulfide is going to have, if we look for sulfur here, it's going to have 16 electrons plus 2, so it's going to have 18 electrons altogether with that extra negative 2 charge. And so the atomic or the electron configuration for sulfide is effectively going to bring it over to argon. So it's going to be everything as far as neon. That's what that abbreviation means there. So that would be 1s2, 2s2, 2p6. So that brings you to neon. Then we're into energy level 3 here. So it's going to be 3s2 and then 3p6, which brings us over to argon. So that's the electron configuration for the sulfide ion. Now we compare that to the chloride ion. It's going to be, well, chlorine is here, and it's gained 1 extra electron, so that brings it over to electron configuration of argon as well. So the chloride ion is going to be the same electron configuration. Everything as far as neon, 3s2 and 3p6. So when we compare chloride to sulfide, the total number of electrons is the same. The highest energy level occupied is the same for both of them. So the only thing which differs is the fact that a sulfide ion will have 16 protons versus a chloride ion which will have 17 protons. So chloride has 17 protons and sulfide has 16 protons. So therefore, if you compare 16 protons holding on to... So I'll just repeat that statement again. So if you compare 16 protons in a sulfide ion trying to hold on to 18 electrons, versus 17 protons trying to hold on to 18 electrons, hopefully it's easy to see that the 17 protons will be more effective at holding on to the 18 electrons than the 16 protons. And for that reason, the chloride ion is slightly smaller than the sulfide ion. So what we'll do here is we'll draw little spheres. So our sulfide ion, let's represent it with that circle right there. And our sulfide ion is greater than our chloride ion. So we'll make that slightly smaller. Okay, let's take a look at the 2 cations here now, magnesium and aluminium. Now, magnesium and aluminium, initially, they start off down in the same energy level, row 3. But what we've done here is we've formed cations, so we have removed electrons. So I'll use a blue color for this. So with magnesium, The electron configuration now has removed one electron, second electron, and brought you back to the electron configuration of neon. So let's just write this down here. So everything as far as helium, so that would be 1s2, then 2s2 for here, 2s2, and then we have 2p6. So that's the electron configuration of the magnesium ion. And let's compare that to the aluminium ion. Well, aluminium has lost 3 electrons to bring it back to the neon's electron configuration as well. So it's going to be everything as far as helium, 2s2, 2p6. So similar to the other comparison, in this case, the two cations have the exact same electron configuration, but again, it comes down to the atomic number. So aluminium has an atomic number of 13, so 13 protons trying to hold on to 10 electrons, versus in magnesium, we have an atomic number of 12, so 12 protons trying to hold on to 10 electrons. So again, for the same argument as before, it should be better or more effective for the 13 protons of aluminium to hold on to the 10 electrons than for the 12 protons of magnesium to hold on to the 10 electrons. So for that reason, the aluminium ion is going to be smaller than the magnesium ion. So Mg2 plus will be smaller than or will be greater, I should say, than the aluminium ion. So now it's just a case of combining the red sulfide and chloride ions with the blue magnesium and aluminium ions. Now the last point here is that, well, because in sulfide and chloride the highest occupied energy level is energy level 3, that means those electrons are further from the nucleus than the electrons in energy level 2 for the magnesium and the aluminium ions. So the magnesium and the aluminium ions were always going to be smaller than the anions. And we have this little meme up here. Well, it's not really a meme, actually. It's just a good piece of chemistry advice. So anions gain electrons and increase in atomic radius. And this is because there is less nucleic pull, or a reduced effective nuclear charge, and more electron repulsion. So the anions were always going to be bigger than the cations. So the final answer for this is sulfide is greater than chloride, which is greater than magnesium, which is greater than aluminium. And that's why the answer to this question is C.